to start off?
Yeah.
All right, go for it. All you.
Hello? Yeah, this sounds good. Okay, welcome everyone. Thanks for coming. I know this is the last session, so I'll try not to drag this long. I'll send you home quick. So today the session is about SolrRDD and how we can use it as a SparkSQL data source. My name is Kiran Chituri, and I work at Lucidworks as a software engineer. In the past few months, I've taken over the lead over Spark and SolrRDD integration, basically for our enterprise product, Fusion. We sell Fusion to customers, and we integrate Spark as part of our stack. So we need a way to connect Spark and SolrRDD together because we want to store the data in SolrRDD. We want to do the processing in Spark. So how do we do it? Tim Potter, he's my colleague, my boss. He actually wrote the library spark-solr. Recently, I refactored it to Scala to implement the data locality. So let's just go through what's it. The high-level overview I want to go through is what is SparkSQL data source? What does it mean by SolrRDD as a SparkSQL data source? How do you read from SolrRDD? How to write to SolrRDD? And how do you do Lucene? How can you leverage Lucene Text Analysis within Spark ML pipelines? So before I start, I want to take a quick survey. How many people here use SolrRDD? That's pretty decent. Has any one of you tried integrating SolrRDD with Spark? Okay, that's cool. Okay, search engines, as you see here, SolrRDD is a standard for enterprise search now. It's been an Apache Software Foundation project for the past 10 years. And here we see 90% of the Fortune 500 companies, they have their own teams implementing SolrRDD. Nowadays, there is more mission critical data, and people are consolidating all their data into stores like SolrRDD. SolrRDD is also being used as a NoSQL data source. In our enterprise product, we use SolrRDD to store everything, and then we use the engine on top of it. So what's it here? What does it mean by SolrRDD as a SparkSQL data source? You should be able to read from SolrRDD. You should be able to write to SolrRDD. So here, when we talk about SparkSQL data source, it's all data frames. There is data sets, but we haven't integrated with data sets yet. But data frames, we work pretty well. So to work with data frames, to create a data frame, you need a schema. And luckily, SolrRDD gives a schema. SolrRDD, since it's implemented, it always had a schema that it comes with, and it always has a schema that represents the data. So here we use a schema API to get this field level metadata, and then we turn this field level metadata into struct type, and then we create a data frame. Once we create a data frame, then we can start getting data from SolrRDD, and then once we get data from SolrRDD, we can connect to it, and then we can access it using the SQL queries, or we can access it using the data frame operations. Here you see there is a sample code here. All you need to connect to SolrRDD is what's your Zookeeper host for your SolrRDD cloud instance, and what is the collection that you want to connect to. Once you do that, once you import our jar file into your Spark shell or your Spark application, you can use the read format and use SolrRDD as the name of the data source to connect to data. And once you connect to data, you can do data frame operations, transformations, and everything like that. Here, I just registered it as a temporary table, so I can use it as a SQL query. So what goes on under the hood, especially when this data source, this SolrRDD data source is connecting to SolrRDD. Let's say I have a collection called nyc_trips, and then this collection has two shards. SolrRDD has a concept of shards. Shard is a logical collection of documents. Shards can be split across nodes, or various shards, or different shards can reside on the same node as well. So here, what I have is, I have NYC trips collection and two shards. And in these two shards, basically the way I want to read data is, there is a SolrRDD that acts as a base that knows how to query SolrRDD, that knows how to go to Zookeeper and get the Zookeeper level metadata. And then by getting the Zookeeper level metadata, what we do is, while telling Spark how many partitions that should be present, we take the number of shards, and then we tell Spark, okay, there are two shards, so you should be able to read these two shards in parallel. So what we tell Spark is use two partitions for it. This is not very efficient. So on the next slide, we will see how we can split this intra-shard splitting, how we can do better splitting within shards. As you know, most of the querying to SolrRDD takes place over HTTP, and we want to parallelize these HTTP calls as much as possible. So here you see, basically within the same shard, we are splitting on a single field. This field can be a numeric field, or a string field, or a date, or a timestamp field. We can split based on these fields, and by splitting on this, we can increase the number of parallelism. So previously I had 2 tasks, now I have 4 tasks. Basically, if you have 100 nodes or a 30 node or 50 node Spark cluster, and if you have a lot of documents, and then you can use this splitting mechanism to dump your entire data from Solr to Spark. After you got your data imported into the Spark application, then you can do machine learning, analysis, aggregations, anything. You can do anything with this data. The thing we want to do is we want to implement what are the different ways to get data, how fast can you get this data, and how reliably. So here you can, I'll show you an example soon, and you can use this to increase the parallelism. You can use the split fields. Basically, this split fields, this example and this example, they both use this select query handler to get the results out. Now, there is another way to query data. In the recent versions, there is something called Soir Streaming API that got added to Solr. So by using this Soir Streaming API, we can read data very fast and very efficiently. But the catch here is it only works for fields that have doc values defined. So what are doc values? So by defining a field, by defining your schema and fields with doc values, we can create a column-oriented data structure. By doing column-oriented data structure, we are not doing the typical inverted index thing. By doing the column-oriented data structure for string fields, or like for numeric fields or timestamp fields, we will be able to read data much faster, and we will be able to do very large table scans. And this streaming API, it's much faster compared to like using a select handler or like using the normal means of getting data from Solr. This streaming API data is usually exported using the export handler. And I'll show you the performance measurements and the example of how the streaming API is used soon. So there is one more thing. Spark gives us the advantage of letting us prefer where the task should be run. So if your Solr nodes and Spark worker nodes are co-located together, then this SolrRDD, it will use the get preferred locations method. It overrides the get preferred locations method, and it specifies, okay, I have these shards and replicas located here. So please try to run this task at this preferred location, at this preferred host name. By doing this, we reduce the HTTP overhead that goes on between different nodes. And soon we are adding the concept of fallback to a preferred replica. So if one of the replica that you are querying goes down in the middle of query, in the middle of table scan, we will fall back to any of your preferred replicas that are present. And also the next thing, how about writing to Solr? You can write to Solr by using the library that we provide. So writing to Solr, all you need to do is you need to specify your ZK host, the collection you want to write to. So here there are two things. The data frame that your data has, it represents a schema, and Solr needs a schema. Solr needs the field names and everything to be defined beforehand. So what this library does is spark-solr library, it will go ahead and create all those fields for you if it's not present. And the fields that we create, we try to enable doc values and everything on those fields. If they are string fields or if they are numeric fields, we enable doc values so that you can leverage when querying by using the streaming API. So far we discussed about how we can read, how we can write data. So the next thing that our library offers is Lucene analyzers for Spark ML pipelines. Basically, most of the people that play with Spark or experiment with Spark, they want to do some kind of text analysis, or they want to do machine learning. So what we thought of is Spark provides us this tokenizing step as part of the ML pipeline, but it doesn't have a lot of flexibility. What has flexibility? Lucene has a lot of flexibility. Over the last 10 years, there are a lot of tokenizing filters, filter factories that got added to Lucene. These filter factories, you can split your tokens and words. You can split your text into tokens, and you can do it in a variety of ways. You can do it for different languages. You can do it to lowercase, or you can split it for paths, or you can use the standard tokenizers as well. By using this, by leveraging this Lucene analyzer, it gives us a lot of advantage in terms of how you can do and what are the options, and it also helps you at the cross-validation step in the machine learning. So here, what we've done is we removed the standard tokenizer with the Lucene analyzer. So, and in the next few slides, I'll show you some examples of how we do this. So here, what we've done is, as I said, using Lucene tokenizing for Spark tokenizing, or machine learning tokenizing, or text analysis tokenizing. So to use this analyzer, all you have to do is you have to define this JSON schema. In the JSON schema, what present is we have analyzers and we have fields. In the analyzers, we define the name of the analyzer, and then we define the character filters, which is optional, tokenizer, and then the filters. And then you define the fields. You can define for a single field, or you can define it for all the fields using the regex. I just want to add that Lucene has more than 35 filter factories available. Lucene supports more than 30 languages for breaking out text, and this is all available in the open source. Like you can go to like the Lucene Java doc, and I think it should be there. Now let's see a small example. I should add another thing. My colleague Steve Rowe, who is a Solr committer and PMC member, he contributed this code to spark-solr. So let's see a basic example. Let's say I want to take the README file of spark-solr repo, and then I want to do a word count. Now, while doing this word count, I want to do different tokenizing. I want to use a different filter. So let's say here in the example, as you see, I'm using a standard tokenizer, and then I'm using a lowercase filter. So the standard tokenizer, what it does is it takes the text and then it splits into tokens. It treats all the white space and punctuation as delimiters. The delimiter characters are discarded, and then all I have to do is I define my Lucene. I create a new Lucene Text Analyzer object, and once I create the object, I'm reading a README file, and then while reading the README file, I'm applying this analyzer to each line there. While applying to each line, what happens is it's getting tokenized, and it's also getting lowercase. And then the next 3 steps are standard word count examples. Here you see the top 10 word count, like the to here. The problem is we get the word count, but we're not so happy with it. Why? Because we see a lot of prepositions and articles, and it's not very useful for us. So let's say how we can use and Lucene has a stop word example. There is a stop word filter factory that can be used to remove these propositions and articles. So here what I've done is I have created another analyzer, and also I use 2 filters here. I use the lowercase filter and I use stop filter. In the JSON schema and within Lucene, the analyzers, there can be only one tokenizer, but you can chain as many filters as possible. So since I'm using the lowercase and stop word filters, the output result here, it doesn't include the stop words. The stop word filter, how it acts is it has a blacklist of stop words against the English language. You can modify this stop word filter by providing more options. For different languages, you can provide your own stop words, etc. So next thing is basically the example we saw here is just basic text analysis in any Spark application. Now, as part of ML pipeline, how can you use this? So the Lucene Text Analyzer transformer, it's an extension of ML pipeline transformer. It supports multi-valued input columns, which not many transformers do right now actually. So in the same way, you define your JSON schema for this analyzer. Once you design your JSON schema, you will create a new analyzer, which is a Lucene Text Analyzer transformer. You create your transformer, set your input fields, set your output fields, and then once you do that, you create your ML pipeline, which consists of this analyzer. Here, I skipped over the example, but the spark-solr repo has a full example of how the 20 news groups, the standard 20 news groups example is written using the spark-solr library. The next thing we want to do is, since the overhead in Solr is most of the times when customers want to index data as fast as possible to Solr, the overhead in Solr always is analyzing the text. There is always that overhead. We can avoid that overhead in Solr, and we can actually do it in Spark. If we do it in Spark, it helps us take advantage of not doing the text analysis in Solr, and it indexes our documents as fast as possible. This is the next thing we want to do is we want to do a pre-analyzed feature. Solr has this field type called pre-analyzed field type, and then we want to send documents. We want to pre-analyze these fields inside Spark itself, and then we want to send this to Solr. So next of all, so how do we use this Spark library, spark-solr library within our enterprise product Fusion? So here I have the basic stack of our Fusion product. So here, as you see, Apache Solr and Apache Spark are the core of our product. We store our data in Solr, we process it in Spark. So to connect both of these, we need a library that should be able to read data from Spark and data from Solr to Spark. So here, as a bridge, we use a spark-solr library here. So we are always going to continue iterating on the development of the product, even though it's open source. We are always going to add stuff to it because our enterprise product leverages it for the processing. So spark-solr library recently had its 2.x release, which had a lot of bug fixes and features. It's built into Fusion 2.4. Just talking about a little bit about Fusion, what do we use Spark in our enterprise product? We use Spark to process our events. So whenever there is a search app involved in a company, the search app might be small, but there are a lot of events, a lot of user interactions that happen around a search app, like people clicking on the links, people making queries, or people not happy with the queries, people going to the second page because they don't like the queries. There are a lot of user events generated. The Fusion product provides a feature to capture all these user events. Once you capture all these user events, you can do aggregations through our product, which are done using Spark. And there is also option of training your model, but when you're indexing to our product Fusion, you can train your ML pipeline, which is basically a Spark ML pipeline. And you can also serve your ML pipeline during our querying phase by using Fusion. And as a last step, you can run your own custom Scala script, which can be anything, and you can schedule it, like run it every 1 hour, 2 hours, or run it every 5 hours. So as a step, what is it? What is this library? So this is the GitHub link. It's open source. It should be publicly accessible. So just go to that link. We publish all our packages to Maven Central and the Spark packages.org. And you should be able to use the packages command line to import the library as well. If you want to build from source, you can do it as well by using this Maven command here. I just want to show a few examples of querying. So the first example is it just goes to Solr. It just reads data from Solr. And then by using this SQL query, it's not doing anything. If the collection has 2 shards, it will use 2 tasks or not. Here the limit happens on Spark side. So next thing we have intra-shard splitting. Now let's say you have 10 million documents and you have 10 shards. Instead of using 10 tasks, you want to use 20 tasks or you want to use 30 tasks. You want to increase the parallelism. All you need to do is enable the splits option to true. So when the splits option is true, by default, it splits on the default field version. You can specify your own field as well here. By splitting on the default field version, you should be able to leverage the parallelism. You should be able to get more tasks from it. And the next is Streaming API. To use Streaming API, you don't need to do anything. If the fields you are querying, here I'm querying 2 fields, tip amount and the fare amount. If these 2 fields already have doc values enabled, then the code underneath, it will use the Streaming API by default. So it determines what fields you are querying, whether those fields, what is the schema of those fields, whether they have doc values enabled or not, then it will automatically switch to Streaming API based on the fields you are querying. So nothing is complete without talking about performance. So let's talk about performance and how does this library fare in terms of reading from Solr and writing to Solr. So here what I've done is I took this NYC taxi data set. It's a 92 million rows data set, and then it's a taxi trip data from New York of Uber, Lyft, and the normal taxis. So the data consists of where the pickup happened, where the drop-off happened, how long was the ride, how much was the fare, how much was the tip amount, all this data. It's all non-text data. So I took this data, I loaded onto this Amazon Postgres RDS instance, and then I used 3 nodes, 3 EC2 nodes of R32X. R32Xs have, I think, 61 gigs of memory and 8 cores. What I've done is I co-located Spark and Solr together. I gave half of the cores, half of the memory to Spark. And then I created a collection called NYC Taxi with 6 shards and a single replication. I've done all this on EC2 by using the Solr Scale toolkit. And then here there are more links on what the data set is and what is the exact thing I did. So let's talk about index performance. First, we want to take the data from RDS and we want to index it to Solr. So the index performance, the docs per second we got is 31K. Since I used only 3 workers, which is not too much, I tried to exhaust this as much as I can by increasing the number of partitions. What I have noticed is by improving the batch size, when the docs are indexed to Solr, it gives better performance. So for example, you can increase the batch. Based on the size of your documents, you can determine how much should go over HTTP at a time. How much should you batch together? I used 5,000 for the batch size from RDS. And then the query performance. Let's look at query performance. I did a simple aggregation query over 2 fields that have doc values enabled. So as you see, this all the fields, all the documents have all the fields. And then the streaming expression, the streaming API export handler, it was able to import 92 million rows, almost 92 million rows in 2.3 minutes by using 6 tasks, only 6 tasks. It used, it consumed very low resources on Spark side, which is very surprising to us as well, because the whole streaming API was recently rolled out. If I do the same thing using deep paging, which is select handler, then it took me 20 minutes with 120 tasks. 120 tasks is exhausting all my resources on the Spark cluster. So what I would suggest everyone is, if you're creating your new collections and you know what type of schema you have, try to use doc values, try to enable doc values as much as you can. If you want to do analytics, if you want to import your data to Solr. So talking about roadmap, what I want to do is, in the future version, we are going to do the following. We are going to implement the data source with catalyst scans, because we want to push down as much predicates as possible, as many predicates as possible down to Solr. Because coming with Solr 6, what Joel Bernstein added is he added the SolrSQL. What SolrSQL can do is it can calculate the operations or aggregate operations within Solr itself. So we want to take leverage of this, and we want to push the computation as much to Solr as possible, because it's not good to import all the data to Spark for every small operation. Since Solr can do the simple computations as well, we should take advantage of the code here. And the next one, as I said, we want to fall back to a different replica if one of the replicas goes down. And for intra-shard splits, we are going to take a look at how to use the HashQ parser plugin. And then the last thing is how to pre-analyze all the text within Solr and then sense the terms. How to pre-analyze all the data within Spark itself before indexing, and then how to send these tokens to Solr. So that's pretty much it for me. As you see, if you haven't tried out how to connect to your Spark cluster, please go to the GitHub link, and you can also download our enterprise product if you want to give it a try. This is my email and Twitter handle. So thank you for listening.
Thanks for the great presentation here. If you've got any questions, please raise your hand, and I will give you the mic.
I'm using currently HBase. From HBase, I'm indexing into Solr.
Okay.
And then we are using D3 for visualization.
Okay.
So we are going to try Spark. So what we are doing is, from HBase to Solr, we used Java MapReduce, already available things. So as of now, I know that we can use Crunch Indexer to index into Solr from HDFS.
Okay.
But what I want to know is there anything else that I can do from HBase and write into, directly from HBase to
yeah, so the question is like, if you should be able to write to Solr from HBase using Spark,
similar
right?
to Java MapReduce, is there anything that is there? Because we are moving away from MR to Spark, that's all.
Yeah, I'm not fully aware if there is a Spark to HBase connector, but I think there might be one. If there is one, you should be able to use the data source.
Yeah, there actually is a Spark HBase connector on.
Okay, then you should be able to use the data source, create your data frame. Once you create your data frame, you should be able to write to Solr. It should be as easy as that.
So I should create a data frame.
Yeah.
Create a data frame from HBase.
Yeah. So similar to this.
There is a connector. I connected to HBase, and all I wanted to know is how to get the data from HBase to. Yeah.
So for JDBC, those are the only 2 lines of code. Like, you provide your options, your connection options and everything.
Okay.
Then you create your data frame. Once you create your data frame, you should be able to write to Solr there.
Oh, I should. Okay.
It should look somewhat similar as here.
Okay. Thanks.
Thanks.
Cool. Any other questions?
So when you index in this example here, the Solr schema is not specified.
Yes.
So the schema is like Solr will compute it on the fly. And
Yeah.
Okay. So what if?
Yeah.
Okay. If I have a fixed schema already on the Solr collection,
then it won't create the fields.
but does it intelligently know how to transform. Like, I mean, I can do more hand coding and make sure that my data frame match exact. But sometimes we do some sort of transformation a little bit. If let's say something, let's say it's like a string to a number. I mean, like it was in the string form, the number itself, but obviously in the schema is a number form. Will the driver be smart enough to do the transformation?
Okay, so the question is, can the library read the schema from Solr, and then while indexing, can it transform the incoming data from the data frame? Currently, I don't think we do that, but that's a good feature to add, because if sometimes people are fixed on their schema, sometimes people want to change it. Yeah. So I understand, like sometimes, yeah. I think it's a good feature to add as a config option. Like if you provide this config option, we will transform your, we will take your Solr schema and then we will transform it. I think, yeah, that's a good feature to add. I'll add that soon.